Okay, so this is the next segment in our BioChem Basics. These are this is the page you have in your notes that is mainly a good summary. That's why I gave it to you. I just want to help divide this for you a little bit and show you that here you have your carbon base nomenclature. And down here, these two rows are your functional groups. So we're going to take a look at these a little bit closer. Even the carbon base names there, we're going to look at them too. But the important ones, if you want to kind of highlight them on your sheet, are these guys. And I don't want to underline that one without having the bottom or cover any of it up. So you're looking at amines, alcohols, ethers, carboxylic acids, and esters as being the most important ones in terms of the macromolecules that we're going to be looking at. We'll be looking at macromolecules that are alkanes. We'll see a couple that might show up as being alkenes, and we'll also look at some phenols. Phenols can also be called aromatics. They are involved in some smelly things, that's where they get their terminology. So let's take a closer look now. Clear our screen out and take a closer look at some of the nomenclature that we were just talking about. The next piece of nomenclature that you have in your packet kind of is titled alkanes, basically because it's with alkanes that we learn how to, kind of number the base chains. Again, we won't ever really be looking at these guys, but it's kind of nice to know when you're looking at names that it's coming from someplace. So if you, see something and it's, a methyl ketone or a diethyl ether or something like that, at least you can understand where some of those prefixes and pieces of those words are coming from. So we're basically looking at the number of carbons. So 1 carbon, 2 carbons, 3 carbons, and then giving them a prefix within the name. So 1 carbon would be meth, 2 carbons would be eth, and 3 carbons is prop, 4 carbons, 5 carbons, 6 carbons, 7 carbons, 8 carbons. That's really as high as we need to go. It's the ones that are going to be most familiar to you anyway. So 4 carbons would be the prefix but. This guy's penta. Now these start to look like geometry words. Hepta over here, and then oct over here. So if we were talking about an alkane, and we were talking about a 2-carbon alkane, then we would have eth, and then the suffix ane for telling us that there's only single bonds between carbons. That's what an alkane is. Maybe I should put that up here. So it's a single bond between carbons. So some of the other ones that you would know, you should know propane. That would be the gas that's inside barbecue tanks if you have propane. Methane is natural gas. Butane is in cigarette lighters, and one that will become important to you later, but not now, octane. Octanes are in gasoline. And the higher the octane, the cleaner the burn. However, the higher the octane, the hotter the burn. And oftentimes, if you put in the wrong level of octane into your engine, you may be burning up your engine and not doing it good. Everybody thinks to use a higher octane is a good thing, but your engine has to be rated for a higher octane in order to use it. So we want to make sure that we don't do that. Okay. Next in your notes, I think you have a page that talks about the alkanes again, which I believe is really more of a typo. It has both pictures of alkanes and alkenes. So just let's kind of summarize what's going on here with all of them. So alkanes, again, are single bonds between carbons, like that. Alkenes are double bonds between carbons, and it only has to be one. It doesn't have to be double bonded carbons throughout. It just has to appear once. We're going to see them in some fatty acids or lipids when we're looking at them. And then we have alkynes, which are triple bonds between carbons. Again, only once is all we need. This is really hard to keep. It's very unstable. And when we play with the molecules and the model kits later this week, you'll get an understanding as to why that's very hard to keep. It's easy to draw on paper, but it's not very easy for carbon to hold on to that. And then the last one, the phenols, I might be going a page ahead or so. The phenols are those aromatic rings where there's a double bond that alternates between the carbons. So you have a double bond, and then you have a single bond, and then you have a double bond, and then you have a single bond, and then you have a double bond. So this alternating ring here is what's called a phenyl or an aromatic ring. The most common one for you would be benzene. Benzene is a refrigerant, and I believe that's the picture that's in your notes. Okay, let's jump ahead a little bit. So the next page is isomers in your notes. And I kind of want to give you that towards the end. So I'm going to skip isomers. Oops. Just so that, in case you wonder what happened to that page of notes, just so you know, I'm going to skip that for now. I want to do that one towards the end in a little bit. So I want to take a look at some of the functional groups right now. That will be our focus for this portion. So you have halides are up next. They're the first group. So you have a carbon, and a carbon, and somewhere off of that carbon there's some kind of halogen. Maybe it's fluorine, maybe it's iodine. Some kind of halogen, that's how they get their names. Okay. Next one up, I believe, is alcohols. And I do kind of want a clear slate to talk about alcohols with you, so let's clear our picture here. Alcohol group is next. And an alcohol group is a carbon connected to an OH. So this is the alcohol group. Okay, you are going to have to be able to identify the alcohol group. So an OH connected to a carbon is the alcohol group. So I want to talk to you a little bit about the most common alcohols, and just because I think you should be aware of the fact of who they are or how we get them, and sometimes what the dangers are of them. So the most common alcohol for you guys is this one right here. This is ethanol. So that's 2 carbons with an OH hanging off. Doesn't matter which side. When you have only 2 carbons, it doesn't really matter. And this is drinking alcohol. Methanol is 1 carbon with an OH and 3 H's. That I just don't want anybody to forget that we are talking about carbon having 3 additional bonds there. This is wood alcohol, and this is really toxic to you. Deadly toxic. I don't know if that makes any difference to anybody, but somebody saying toxic to me would make me worried no matter what. And then the last one we have here is propanol. And if the OH group or the alcohol group appears on either of the N carbons, then you have propanol. The isomers, and what we're going to talk about being an isomer, is a change in the position of the OH group. If we change the position of the OH group, we can get a isomer called isopropanol. That should sound familiar to all of you. And that would be, whoops, let's get rid of that. What happened here? What happened here? There we go. There it is. If we put it in the middle here. If we put it on the middle carbon, then we have isopropanol. So those are our alcohol groups. Isopropanol is rubbing alcohol, in case anybody was curious or doesn't remember that. Again, drinking alcohol, and then wood alcohol, which is toxic to you. Those are the most common alcohols that you guys would come into contact with. Okay, let's move forward. Next in your list or in your note packets are the amines. They can be a carbon with an NH2, but sometimes you'll see them be a carbon with an NH3. And they're going to play an important role when they are combined with another functional group in something called an amino acid. So you're going to have a carbon connected to our NH2, connected to the carboxylic acid. So this guy right here is our acid portion. This guy right here is our amine portion. This is our carboxylic acid group. And these guys are important to us because they are the monomers for proteins. They're our base unit for proteins. So we're going to see amines always connected to that acid group there on our base carbon. And that's where they're going to become important to us. Okay, who's up next? Up next is our ether. Our ethers will always be involved with alcohols because they are, oh, I didn't switch back to blue. they are going to be a major component of our carbohydrates. So an ether group is an oxygen that sits between two carbons, and the reason why we talk about them mainly in carbohydrates is because carbohydrates we're going to talk about exist in rings, and they play an important role in ring structures. In ring structures. So I was drawing a ring structure with a carbon before in that corner of that ring. But this time we're going to put our ether there. And that does something very particular to this portion of the molecule. Basically what it does is it blocks further bonding. So that makes this really stable, because nobody else can get in here. There is no getting into those bonds because the oxygen has bonded to those two carbons. And so that's what makes a really stable ring structure. So it's really important to the carbohydrates that are mainly rings, which we'll see in a day or so. Okay, after the ether, we have the carboxyl groups, or the carbonyl groups, all together on one page. There's a nice chart that you'll find in the additional resource section, where it gives you all of the different functional groups and examples of them. But right now we're going to look at the carbonyl groups, which includes one we already saw. Basically, the name is coming from the carbon with the double bonded oxygen. That is carbonyl. Who is also there is what makes the difference. So we've already talked about carboxylic acid. That's that guy there. You also have the aldehydes, like in formaldehyde. Formaldehyde is the most simplest aldehyde. You have the H, you have double bonded O, and then you have another H. And of course, you know, formaldehyde is what's used in embalming or preserving humans or animals. Then we have the ketones. Sounds like a band. And just to make sure you know, you can have carbons out the wazoo over here on both sides of this. But as long as you have a carbonyl group surrounded by carbons on the other sides, you have a ketone. And usually the ladies of the group are the most familiar with ketones, because nail polish remover is acetone. Acetone's one of the most simplest ketones. You have the C, the carbonyl group, and then you have CH3 over here and a CH3 over on that side. And that's your acetone. Okay. Just one more left, and he's going to become important to us when we're talking about lipids. That's where we see esters. They make things taste good, which is why they appear in lipids and why we like lipids so much. An ester is really the combination of a ketone and an ether. So you have double bonded O to the C to whatever else is over here, to an O to a C. So here's your ether portion there, and this is our ketone portion right there. So I would say Uncle Ketone married Aunt Ether, and they had baby Esther. And that's how you remember that that's what that is a combination of. All right, that pretty much sums up our functional groups. So let's move into the next segment to talk about isomers.